Hi everybody, myself I am Shekhar. Today we are going to discuss about pin description of 8051. All these 8051 families come in different packages such as DIP, dual inline package, QFP, quad flat package. So here all these are going to have 40 pins and these pins perform various functions such as input output operation, read operation, write operation, transferring of address, transferring of data and interrupts. So these are the functions that each pin are going to be performed. But some of the companies are going to provide a 20 pin version of the 8051. Or rather than 40 pins, some of the companies are going to provide a 20 pin version of the 8051. In 20 pin version of the 8051, input output ports are going to be reduced and mainly used for the small applications, that is where are less demanded applications. But coming to the practical world, most of the developers are going to be use 8051 in 40 pin version. In these 40 pins, a total of 32 pins. This one, port 0, port 2, port 1, port 3. In these 40 pins, a total of 32 pins are set aside for 4 ports, that is P0, P1, P2, P3. Each port consists of 8 pins. The remaining pins are a VCC, ground, see here, pin number 40 VCC, pin number 20 ground, and pin number 1819 XDAL2 XDAL1. And next, external access, program store enable, that is 31 30 29. Okay, let us discuss pins in each in detail. The first one is VCC. So here pin number 40, let's see here. So here we are going to supply voltage to the chip. So the voltage is plus 5 volts. And next one, ground. Pin number 20 is grounded. And next the other one, yeah, pin number 18 and 19 XTAL2 XTAL1. If you see the block diagram of 8051, of course 8051 has an on-chip oscillator but requires an external clock to run it. That is nothing but 8051 has an inbuilt oscillator or on-chip oscillator but requires an external clock to run it. Mostly quartz oscillator or quartz crystal oscillator is connected to the inputs of XTAL1 and XTAL2. The quartz crystal oscillator connected to XTAL1 and XTAL2 also needs two capacitors of 30 picofarad value. And in this one side of each capacitor is going to connect it to the ground. Yeah, let us see in diagram. And one more point, the speed of the 8051 family microcontroller depends upon the maximum oscillator frequency connected to XTAL pins. That is nothing but the speed of this microcontroller depends upon maximum oscillator frequency connected to XTAL pins. Let us see an example. A 12 MHz chip must be connected to a crystal with 12 MHz frequency or less. Just we need to connect in between or less. Or let us see one more example. A 20 MHz microcontroller requires a crystal frequency not less than 20 MHz. And the next pin is a reset pin. Pin number 9 is the reset pin. It is an input and active high signal. Upon applying a high pulse to this pin, the microcontroller will reset and terminate all current activities presently. This is often referred to as an power on reset. And the next pin is external access, that is pin number 31. External access pin indicates the 8051 is accessing from internal ROM or external ROM. Then we can simply say that whether the 8051 is accessing from internal ROM or external ROM. We can decide in simple manner if external pin connected to VCC. The 8051 is accessing from internal ROM. And one more point, if EA pin is connected to ground, then 8051 is accessing from external ROM. Simply we can say that if EA pin is connected to VCC, it is accessing from internal ROM. If EA pin is connected to ground, it is accessing from external ROM. And one more important point, it cannot be left unconnected. In combination of PSEN and EA are going to use to access external ROM. And the next pin is PSEN, Program Store Enable. This is an output pin. This pin is going to connect it to the OE pin of the RAM containing the programming code. That is nothing but we can simply say that the Program Store Enable pin is going to connect it to the external ROM. The external ROM's OE pin, Output Enable pin. To access external ROM containing programming code, we are going to use this PSEN. When external pin is connected to ground, external access pin is connected to ground, the 8051 fetches opcode from external ROM by using PSEN. So this is the points about Program Store Enable. Next, ALE, Address Latch Enable, 30th pin here. Pin number 30. AL is nothing but Address Latch Enable pin. So it is going to be used to demultiplex the address and data. Simply we can say that when AL equal to 1, the ports P0 and P2, the ports P0 and P2 lines has address in it. These lines are having address in it. When AL equal to 0, the ports P0 and P2 has data in it. Simply we can say that if AL equal to 1, the lines is having address in it, and AL equal to 0, the lines is having data in it. And next, coming to the ports, as we discussed in our architecture of 8051, that is P0, P2 and P1 and P3. Simply I will discuss in briefly. So all the 4 ports are used for input output operation basic point. And second one, port 0 needs pull-up resistors. Why? Because it's an open drain. 10 kilo ohm pull-up resistors are going to be used in port 1. And for coming to port P1, P2, P3, already they are connected internally, so there is no need of pull-up resistors. And one more point, in combination of P0 and P2, so it is going to access, these ports are going to access external memory of size 64 kilobytes. So 16-bit address is going to be transferred to an external device by using P0 and P2. The lower address is going to be used in P0 and the higher address is going to be used in P2. And coming to port 3 is having multiple functions along with input output transfer. So whenever a serial communication is there, so by using P3.0 and P3.1, so that is receiving transferring is going to be occurred from 10th and 11th pin. Like that, interrupt 0, interrupt 1, timer 0, timer 1, read, write. So port 3 is having multiple functions. Yeah, this is the concept of pin description. Thank you guys. Please subscribe my channel.